All right, welcome to lesson 3. Today we're going to talk about object-oriented programming. So we have some goals with the object-oriented programming and why we want to use it. And these are our design goals when it comes to creating large systems or any system at all. And these three are quite simple. It's robustness, adaptability, and reusability. Robustness is going to allow us to validate our inputs and outputs. We want a system that's adaptable, so if we have to make changes over time, it can handle both new hardware and software. Uh, a lot of the operating system stuff you don't have to worry about because Python itself actually takes care of that for us. And then we have reusability, which we want to write small components that can be used throughout multiple systems. And what that means is we want to write functions. Let's say we need a function that reads a feature class. We shouldn't have to write it hundreds of times, that logic throughout our code. We write one function, call that function itself. So it makes it a little easier to maintain if we have a problem. So let's say there's an error in that function. Instead, if we wrote that logic 1,000 places within our code, we have to update it 1,000 times. If we use this a function instead, then that code can be changed once and it fixes the problem throughout the whole system. So the basics before we get started is that you need to know that Python is an object-oriented programming language. This means that it supports all the features of object-oriented programming design, and it helps developers handle the complexity of code. So our principles, there's 3 of them. We're going to look at modularity, abstraction, and encapsulation real quick. So first, modularity, we're going to make up our package or our library of multiple modules, and we're going to link them to combine a full system. So think of it as, let's say we're using the request package. Request package isn't just a single .py file. It's a folder-based structure and it has multiple modules within it. And we can go ahead and we're going to link them together by doing importing from various areas and form all that logic together to build a complete system that allows us to make web requests very simple. Then we have abstraction, which is another component of OOP, and it's going to allow us to hide the complexity and only show the essential features that we need. Our system on the back end can be very, very complex. It could be doing all types of calls and calculations, but the user only really needs to know the end result and the one function that we do it. They don't need to know how everything is done. So we hide the stuff that we don't want the users to use, even though we might have all these other functions and classes to do it, and we only give them the essentials that they need. So let's take a look at how that works. So I'm going to create 3 classes here. I'm going to have a base class called an abstract base class that's going to inherit from ABC. I'm going to call it payment. And this is my base payment class. And our base payment class is going to allow us to have some inherited functions in it. So we have a payment class that we declare an abstract method, and then we have what's called a payment slip, and it takes one variable called amount. So we can go ahead and then inherit payment for a credit card payment. So we consider this to be our base class, and now we're going to start inheriting from there. So for our credit card payment, it's going to have all this stuff, but then we're going to go ahead and overwrite our payment method that came in from the abstract method. So we say def payment, the amount, same input here, but now we print out credit card payment of and the amount that was specified. If the same thing happens with mobile wallet payment, we inherit from payment, which is our base class. It gets all this information, and then we override payment to make it fit the logic that exists within mobile wallet payment class. Now let's take a look to see what happens. First, we'll run the credit card payment. We'll create the variable, make a payment of $100, and we should see the change. We expect this, credit card payment of, and then the amount. And then we're going to run the print slip, and we're going to get this generic purchase amount of whatever. And then we're going to do an instance object, and we can do either an is instance by payment or by credit card payment, and we should get back true. And we're going to do the same exact thing for mobile wallet. and everything will print out at the bottom. So let's go ahead and run this. So we get our first expected statement of credit card, and we can see for mobile we get the expected statement, and we can see we have that generic base class function that came through on print slip for both of them. So what we were able to do is we updated the class that we needed to update to be very specific for the logic of each class, but the generic stuff we only had to write once. So you can see how we reduced the amount of code we had to write quite significantly. Now imagine if you had lots of functions and lots of methods that did this. If you have commonality between all different classes, let's say it's a geometry class and you wanted to buffer, it's the same, or you needed to get back the 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 data as a GeoJSON or something. You can write one function in here and then have it inherit that into your child class, and then you have all that functionality in there. So with encapsulation, what we're trying to do is we're trying to restrict our access to methods and variables. Now Python doesn't have a true private and method or a restricted class or anything like that, or protected classes. Um, so what you do it is you do it through underscores. And there's two types of ways you can do that. So there's the double underscore and the single underscore. So I could say, I could create two. So I can have the double underscore max speed, double underscore name, and single underscore, and then the name. This means private, and this means don't touch, basically, what the two underscores mean. So here we're going to create our initializer, and then we're going to set underscore underscore max speed and underscore underscore name to some initial variables. And then we're going to have our function drive, and then our set max speed function, which is going to set the value back to our class variable here. And basically, what we're doing here is we're setting these variables, and a user knows when, let's say they do the code completion, not to touch anything with these double underscore variables, whether it's a function or it's a variable in this case, modular variable, class variable. So we get our expected, we get our driving, because we had our initial value of 50, so the max speed's 50, and then we set it to 320, and now our max speed is 320. So in summation, in this quick lesson, is that OOP is really helpful. We're going to use the double underscore to say, hey, this is private, do not touch. We'll use a single underscore to say, hey, you can touch this, but don't really monkey around with it. Then we're going to use modularity to help us build our larger systems, and then we're going to use abstraction to hide the complexity of our system, so what we write is easy to use for our end users. All right.